Hello everybody. In this video we will discuss reaction of aldehyde or ketone with reducing agents such as sodium borohydride or lithium aluminum hydride. So let's begin this reactions right here. So we have acetone CH3COCH3, that's our ketone, and then we have reducing agent sodium borohydride. It doesn't matter which one you use. Sodium borohydride is slightly milder and safer than lithium aluminum hydride. So let's say you have sodium borohydride. So your reactions, like if you are trying to solve this problem like this, your problem would be a lot easier if you consider sodium borohydride. It would react as if, so this would serve as a source of, so this would serve as a source of hydride ions. Both of these, okay, so both sodium borohydride and lithium aluminum hydride. So what is an hydride ion? Hydride ion is basically hydrogen with 2 electrons. That's anhydride ions. So based on the knowledge that we have about aldehyde and ketone so far, we know that oxygen has delta negative and our carbon has delta positive charge. And you see here there is a negative. So where there is a negative ion here, so where do you think this would go? This would go obviously towards the positive terminal, right? So this would go and attack, this hydride ion go and attack right here. Now, so far all the reaction that we have done, every time a nucleophile attacks the carbonyl carbon, now you have 5 bonds. So to maintain the octet, the pi electron will move towards oxygens, right? So let's do that. So our pi electron would move towards oxygens. So what is the intermediate we will be making here? So intermediate that we will be making here, it's going to be CH3CO minus and CH3. And then here we will have our hydride ions, right? So that's it. So now all we have to do is neutralize this proton. Some book you will find they will write the O minus counterbalanced by sodium plus. It's okay if you don't write it, that's kind of given. And then last thing we just have to do is neutralize this with some sort of proton, right? So you can some book will say simply H plus, some book will say H3O plus, some book will write just water. All it is doing is adding an extra proton from anywhere you like. Okay, so I will just keep it simple, H plus or H3O plus. So our product for this reactions would be CH3OH, CH3, and there is already a hydrogens right here. Okay, so you noticed we started with a ketone, right? So our ketone get reduced. So this is a reduction process. Because why it's called reduction process? Because if you notice, we added a hydrogen and hydrogen. Every time you add a hydrogen, that's called as reduction process. So this process gives us a secondary alcohol. So ketone get reduced to secondary alcohol. Okay, so now let's look at where is the source of this hydride ion. So if you do this in your exam, I'll give you credits as well. But the proper way to do this is, so sodium borohydride is it's gonna give you sodium plus and borohydride ion H, 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 and the boron gonna have negative charge. Okay, so the way the reaction would happen is one of the hydrogen will serve as the source of the hydride ion. You see, so this hydride ion, where it is coming from? It's coming from one of the hydrogen from the borohydride ions. Okay, so the proper way to draw the mechanism would be, you take here, okay, let me delete this. Okay, so I will add this hydride ion here. So this hydride ion, along with its lone pair, is attacking the carbonyl carbon, and then we go from there. Okay, so let's do let's add a little bit more details. So if you remember what kind of hybridations we have here, this was sp2 hybridized carbon atom, but now we got sp3 hybridized carbon atom, right? So the sp3, which is tetrahedral intermediate, that's our so this one is sp3. This is your tetrahedral intermediate. Okay, so when you have a tetrahedral intermediate with a O negative ion on one of the on one side, usually what it does is it wants to get back to its glory days of sp2 hybridized. It wants to stay in this form by removing one of the group. But in this case, if I remove this group, this would be CH3 minus, which is a very bad leaving group. This one also hydride ion, which is a bad leaving group. This one also is CH3 minus, which is also a bad leaving group. So as a result, it cannot kick any groups out. But later in the semester, when we look at later videos, when we react with an ester with the lithium aluminum hydride, you will notice a group will get out, will be out. So same thing will happen if you have lithium aluminum hydride, which is also the serve as a source of lithium plus, source of hydride ions, H, 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 and H. So one of this, so there will be a negative ion here. So one, let's make it prettier. Okay, so one of this hydride ion will serve as a source of hydride ion. So this would serve as a source of H minus ions. Okay, so let's do one more problem before we move on. So let's say we have something here, another ketone. Okay, so and we try to react this. Let's say this time we react with lithium aluminum hydride. Lithium aluminum hydride 1 and 2 is H3O plus. So remember, 1 and 2 means you are doing one's first step of the reactions where you are treating with lithium aluminum hydride first, and in the next step you are dumping H3O plus. Like, we are not mixing both of them together, otherwise it's going to cause an explosion. Okay, so what would happen? So I'm going to draw the mechanism here, and then we'll draw the products finally. So let's try to do this one. So lithium aluminum hydride, so what it has aluminum hydride. So let's draw it out. Aluminum hydride, 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 hydride. Aluminum hydride has negative ions. So one of this hydrogen with the lone pair, with the bond pair, will serve as nucleophile. So would react, like for problem solving purposes, would react as if this is H minus. Okay, so the carbon atom here has delta positive. So this is negative, this is positive, so they would react. And oxygen's gonna have delta negative. So what would happen to the pi electron? It would move towards oxygens. So the intermediate that you will be making is gonna be O minus. And here you're gonna have hydrogens. And then the last thing we're gonna do is react with H3O plus. That's basically neutralizing the negative charge on oxygens. So the product would be, okay, since just keep this in mind, because let me explain. So this becomes OH and H. Again, you don't need to draw the hydrogen. If you don't want to, you can leave it like this, OH as your answers. Okay, so but I'm just going to draw it out so that you can see that we have added a hydride ions right here. Okay, so again, we started with a ketone and we ended off a secondary alcohol. Let's do one more example and then we'll call it a day. So let's say we have an aldehyde. So let's say we have an aldehyde, COH, and then you are treating with sodium borohydride with and then H3O plus. So this would serve as a source of borohydride ions, source of hydride ions. So let's say this go attack here, push the pi electron towards oxygens. So that word becomes O minus H, and we added a new H there. And then all we're gonna do is neutralize by H3O plus. That's basically gonna neutralize this O negative ions. So our answer would be cyclohexane, and then this is O, H, H, and H here. So you see we started with an aldehyde and we ended up with a primary alcohol. So when aldehyde gets reduced, you make primary alcohol. When a ketone gets reduced, you make a secondary alcohols. Okay, so this is a primary alcohol. Why this is called primary? Because the carbon atom connected to oxygens is connected to one more chain and two hydrogens. One thing you want to keep in mind, if there is a stereocenter coming out here, not in this case, but if there is a stereocenter here, you're gonna get a racemic mixture because our sp2 hybridized is planar structure, so the nucleophile could approach either from the top or from the bottom. So the product is gonna be a racemic mixture if it is a stereocenter. Okay, that's keep in mind. All right, let's stop here.